Good evening, everyone. Welcome to another session of SQL. My name is Godwin Osabute, and today we'll be looking at the order by clause, which is part of the select statement, and also we would digress slightly into the concept of joins, which is quite an interesting topic in SQL. And as we progress, we will bring the other statements in one by one. So let's quickly look at the order by. Is it clause? Sometimes when you are the order by clause. Okay, let's see how this works. So let's first of all select, so let me select a database. I believe everybody was able to finish the assignment I gave on creating a database and loading those files. Who was able to do it? Who was able to finish it? Can you?
I did.
Pardon? Can you confirm who finished it?
I did.
Okay, that's fine.
I did as well.
I did as well, but I'm at
That's-
work. I won't be able to share.
I
That's
did
cool. No
too.
worries. No worries. I'm not asking you to share. Catherine, you also did?
Yes.
Okay. It was pretty easy, wasn't it? It's something we've
Yes,
done
it was
before.
quite straightforward.
Yeah.
Yes.
Yeah, cool. So you have those databases, and so you should be able to practice with them on anything that we do. Now, the most important, it's not so much as having the specific database which we use in class. It's you being able to vary queries on different databases. So when you are in a workplace, you're not going to get one data set. Data sets will come and to be something that you haven't even seen or you don't know about. It's the same queries that you would run on these databases. So it doesn't matter which data set we are working on, so long as you have the names right and you have your queries right, it will run. It will work perfectly fine. Yeah.
Okay.
So let's see. We want to look at the order by clause today. Let's use the AdventureWorks, which I believe everybody has. First of all, let's do a general select.
Are you going to share your screen?
Am I not sharing?
No, you're not sharing.
Oh, I see. I thought I was sharing, honestly. I thought I was sharing. Apologies. Can you see my screen?
Yes.
Okay, so we want to select all from the employee. Let's see what we have here. We've done this before, but no problem. We want to use this to do certain other things. Right. So we have a whole range of attributes here. We have a whole range of attributes. And you see, I keep using the word attributes, columns, fields interchangeably so that you know they are one and the same thing. We have a whole range of attributes here. If you pick just this one, who can tell us what the order in this is? Can you see my screen?
Ascending order.
Okay. Okay, ascending order. That's nice. I like that. How about this?
Just
Random
like
order.
Pardon?
a random order or something.
Okay. How about this?
Just first names.
Okay. Is there an order there?
There's no order.
There is no order. There is no order.
On
Now,
order.
can we bring, yeah, somebody wanted to say something?
So I just said on order.
Okay, okay. Now, can we bring order to these fields that are not ordered? That is the most important thing. Can we bring order? Obviously, we have just seen when we look at this, there is a default order, which is based on the primary key of the table. Now, employee key here is the primary key. So that is ordered automatically in ascending order. So that tells us something about the order by clause. The order by clause would automatically order a selected attribute in ascending order. I'll take that again. The order by clause will automatically order an attribute, a selected attribute in ascending order. That is the default position of the order by clause. So where an attribute has not been intentionally selected, the order by clause falls on the primary key, which in this particular instance is this field here. It falls on this, right? And you would see that it has ordered this in ascending order. Fine. But can we change the order to something else? Yes, we can. We can select any one of these attributes, other attributes. Assuming, for example, I want to tell you, or your manager tells you, Owen, can you give me the all the list of employees in our company in ascending order? The names of employees, if they just tell you the list, you can just go and give them this one. It will still, you wouldn't be wrong. But if they are specific in saying, can I have the names of employees in ascending order? Then what are you going to do? Immediately, this primary key is though it's important, it is not significant within the question anymore. What becomes significant now is the names. That is what you want to look at. So you want to order the names in ascending or descending order. And that is what we want to look at today. We will look at that briefly, maybe for about 30 minutes, and then we would quickly look at another topic. You know, this actually is not a very long, it's not a very long topic to treat. So let's say that we say instead of selecting everything, we say we select first name. Since we are to just first name, how is first name written? First name is all one word. First name, last name. Select first name, last name from dim employee and order by let's say we want to order by last name. Let's order by last name. And let's just see what is going to happen. Before that, let's just do this. So this will just give us the first two columns, right? It just gives us the first two columns. Can you see? Let me increase this a little bit. No, it doesn't increase the output. It just increases the... Okay, so this gives us that. Now, if we order by last name, then let's see what is going to happen to this. Now, we have not specified which order that we want. But like I just said a while ago, the order by clause automatically, as a default position, orders by ascending order if you haven't specified. So it doesn't matter whether we specify or not. If we want to write this as ascending, ASC stands for ascending, it would give us the exact same result because it is the default position, right? It is the default position. However, if we just want this in descending order, then we change the position to that. And straight away, you see that we have these coming up first. Do we get that? So this is pretty easy, isn't it? You can use this to order anything, It doesn't matter whether it's names, whether it's numbers, whether it's price, whether it is territory. It doesn't really matter at all. So long as you know which attribute you want to order on, and so long as you know how you want your ordering to be, whether in ascending or descending. Obviously, if it is in ascending order, you don't need to specify whether it is ascending or descending. If you want it to be ordered in ascending order, you don't specify. You may decide not to specify this ASC. It would automatically order it in ascending order. So once you have this statement written, order by, and then the field name or the attribute name that you are ordering on. Okay? Now, let's see something. We've selected two attributes here, first name, last name. First name, last name. Let's see something. Can we order on both? Can we order on both? Let's see something. We've been dealing with last name, so let me just make this first name. First name. Let me make this ascending. Which of these do you think will take precedence?
First name.
First name. Okay, let's try it and see. First name. Yep, so the first name has taken precedence. Now let's see if we have two or more first names. Let's see if we have two or more. If anybody spots two or more, let me know. Yeah, Andrew. We have Andrew. We have Barbara. Okay, let's just take these two because this is what we keep. There are a whole lot of rules, almost 300 rules, but this is what we can see on the screen. So let's just use this to explain. Now, let's take Andrew. So after it has ordered by first name in ascending order, then where there are duplicates or multiple or repeated names for first name, what happens? It then switches to the last name and then orders the last name also in the specified order. So you see that it has switched. When it did Andrew, first Andreas, then Andrew, because Andreas came before Andrew. And then once that was done, it takes a C before an H. In the same way, look at Barbara. It takes a D before an M. I'm sure we will see a few more. Let's see if you'll see a few more. Brian. Yep, we have a lot of Brians here. So Brian Goldsmith, GLLW. What comes first? Okay, that's W is the last one. W is the last one here. And then a different version of Brian. Baker before Walton. Chris Nord, Chris 𝐂𝐎𝐓, or whatever it's called. Preston. Do you get the gist now? So just by writing the right query, you can have your output in the order that you want. So since we all have the AdventureWorks database, you can just try this. And then we can also, let's see, we can also do, let's see if we do this descending, whether we will get the same or different results. I believe you know what we will get already, right? Again, it has ordered first name descending. What has happened here? Let's see what happened here when we did this one. Let's see if there's a difference. Okay, okay. Let's see if there's a right. First name, last name is cut right. So why has this not changed? Have I lost my database? I expect this to change. One moment. Yep, this is what I'm expecting. Descending. Okay, let's me do first name here and see. Who knows where the error is? Who can spot the error? Can anybody spot an error?
No comma.
Is it in the GESC?
Yeah, but what caused the error?
You didn't include comma.
Beautiful. That's all I'm looking for.
Oh, okay.
First name descending. Last name, so he sorts first on the last name. Okay. So let's see. I want this first. Can anybody notice anything? Who has noticed anything? Who has noticed anything? Nobody? So it still keeps the order, the ascending order on the first declared attribute, and sorts in descending order on the last attribute. Now let's look at one other thing. Let's look at one other thing. One moment. Can we use both ascending and descending? Can we use both ascending and descending? Yes, we can. So here we can specify order by first name, descending, and last name ascending. Let's see what happens here. One moment, I have a call. Let me quickly pick and I'll come back. Just a minute. Right, so who has any question on these? On what we've done so far? Any questions?
I can't actually see this last one you ran. I can't
Oh,
actually
you can't see it. Okay, let me lower this thing. Can you see?
No, I meant the examples. Sorry, the attributes. I can't see where it ordered first name descending and last
Oh,
name.
look at the results. Look at the result. The first name is in descending order. Can you see that?
Yeah,
And the last name.
yeah, but the last names are all
Okay, don't worry.
like
Don't worry.
I normally
I get what you are saying. I get what you are
yeah.
saying. Don't worry. So the first thing is
Because
that it
the
will
only name there that I could use to check is Williams, but it's the same name, the same
okay,
surname.
not to worry, not to worry. Let's scroll down. Let's look for where we have repeated. So look at Susan, for example.
Yeah, got it. Yeah, yeah.
Yeah. And then look
And
at
Stuart.
Stuart.
Yeah.
And then look at
Sheila.
Oh, all is word.
Same thing.
Um,
Scott.
you get the point.
Yeah, yeah, got it.
Yeah. Peter Connelly, Peter Krebs, Pete. Okay. Paul. Yeah. So it will do the ordering. You just need to give it the right instructions, and it will do the ordering for you. Okay.
Okay.
Any questions so far, so that we can jump onto joins? I think we did aggregate functions some time ago, right?
Yes, we did.
Okay. Okay, cool. If there's no question on this, let me jump.
Or from me.
Are we good?
Yes. Yes, please.
Catherine, are we good?
Yes, we're good.
Cool. This thing wants me to sign up, and I don't want to sign up. Okay, so let's quickly look at joins. Okay. Joins. How many of you did what is called I'm about to ask the question and I've forgotten the name. Okay. How many joins do we have? A lot of people will tell you when you ask this question, or who has heard about the concept of joins in SQL before?
Not me.
Joins.
I've heard the term.
Okay. Okay. Yep. It's quite a popular SQL concept, and it actually has its origin in mathematics. Where you have intersecting intercepts, where you have things intersecting and stuff like that. Where is what I just drew? So assuming, for example, that I want to move this. It's not gonna move. Assuming I draw this one like that. Is there a join here? Yeah, we have a join somewhere here, right?
Yeah, like a
We have a
subset.
join here. Now, so this simple diagram here has got many parts to it. This can be described in totality as the whole of this or just this bit. Do you get that? So we can just look at this intercept here, where the two meet, where the two intersect, or we can look at the whole thing, or we can look at one part. Another thing we can do is look at one part. So we can look at this in actually 4 different, or even let me get this out. We can look at this as this, and also we can look at it as that. This didn't come out well. You get the point. So we have how many parts here? 1, 2, 3, 4. For just these 2 circles or 2 oval shapes that we have drawn. The results of these 2 meeting together can be looked at in many different ways. Now, this is where the concept of joints all comes from. So, how can we interpret this? How can we interpret just this one? Don't mind my drawing, I'm not. I'm using So let's look at this, just this part. Who can describe what has just happened here? How will you describe this? How many people did mathematics in secondary school? We came across this concept, right?
Yeah, subsets.
Sets, yeah.
Yeah, sets and subsets.
So what is this bit?
The joining face is like this. Is it a subset?
Okay, but what is it here? How will you describe this, just this small bit here?
Intersect.
Okay. So explain that to someone in primary 1 or primary 2.
One circle intersects with another, and that the area where they
Don't use the word intersect.
one circle joins another or merges with another circle.
Okay, don't use the word merge. Don't use the word join. All right, let me help you out. So this point here, this area here, is the area that is common to both oval shapes.
Yeah.
It is the area of commonality. So here is where anything that is inside, so this part here shows where things inside here and things inside here meet. Okay? So if we want to become a little bit more technical, we can say that this here is where there are matching records in both sets. This set, the records, this is a point where the records in this set match with the records in this set. Does that make sense?
Yes.
Yeah. Now, on the other hand, so keep that like we would say in Nigeria, keep that in your left hand. Let's see. I want this thing out of my screen and it is not going away. If we have this, how about this bit here? What will you say about this bit? And when I mean this bit, I don't mean these parts. I just mean this bit with that. Do you get what I'm saying? Just this bit. I don't mean these bits here, because obviously these two bits here have got nothing to do with this here. Who can describe what is happening here? Okay. Again, let me just say that. So for this one, we see that this one contains everything that is in this table plus matching records from that table. Assuming these are tables, right? Everything that is in this plus matching records from that. And in much the same way, actually we can color these things. Assuming we have this here, no, I don't want this. So obviously you would see that this and that are opposites, aren't they? So for this, the explanation will be that everything that is in this table plus matching records from that table. Now, if we were to look at this other one here, then this one will be what? Everything that is in both tables. Everything that is in both tables. Right. So let's go back to give some context to this. So we have six main types. A lot of people will tell you 4 types of joints, but it's actually 6 joints. We have 6 main types of joints. Just join. The word join. Now, join alone has got a number of variants. Then we have left join. We have right join. We have what is called cross join. Who has heard of this before? We have 1, 2, 3, 4. We have what is called self join. Oh. And we have I want to put this under that. Okay, let me just put it here, inner join. These are the 6 types of joins. But like I said, this first one has got a number of variants. Let's go back to our drawing here. This is a join. And we are looking at the totality of everything. And we can therefore call it full join, right? Full join. We can also call it full outer join. Full outer join. But really and truly, the word outer is actually redundant. So it is not useful within the term. So we would not use that word. There's no point to flog it. The word outer can also come with the left and the right. Full left outer join, right outer join. All of those, the outer doesn't really matter at all. It doesn't matter. So we can just do away with the outer joins. So it's just for you to know that there is a join or full join. This and that. Let's see what happens. Let's see what happens. Inner join. So let's, for example, take the AdventureWorks database again. And let's say we select everything from employees. From dim employees. And let us give it an alias. Do you remember aliases? Let's give it an alias E. So instead of calling the name dim employee, we just call it E. Let us also select another table. Let's say dim sales territory. Let's look at these two tables. Okay, this is too big. Let me just execute one by one. I thought both would show at the same time. So in dim employees, what are the attributes we have? Now, when you are joining, you need to look for attributes to join on. Right? You need to look for attributes to join on. So let's look for something that is common to both tables, and then we join on that. Is there anything that is common? Let me see.
Employee key.
Let me see. I don't think so.
No employee key.
Sales territory key. We can actually join on the sales territory key. You can join on the sales territory key. Okay, so let's say we want this as T. Sales territory T. Right? And let's say we want to inner join these two. Let's see if it will work. Select all from select all from this inner join. Now, how do we join these? So to join these now, we join on. One needs to join on the order. One needs to join on the order. E dot sales territory key. E dot sales territory key. E dot employee. Let me do that first. E dot employee key. We have employee key, right?
Yes.
E dot employee key. No, we don't have employee key in sales territory. We don't have employee key in sales territory, so we can't join on that. Okay, let me look for another table. Let me look for another table. Sales territory would go with geography, wouldn't it? Geography. One moment, guys. Sorry. So let's see what we have here. In here, we see we have, do we have sales? Yeah, we have sales territory key. And if we go into sales territory also, if we go into sales territory, we have sales territory key. So we can join these two. We can join these two. So let's assume that we select all from, say, dim geography, sales territory, and dim geography. Let's use this instead. This gives us sales territory key. Yep, we have that here. And in this, we also have a sales territory key, so we can join on these. Okay, so let's assume that I call this G. Okay, let's call this G, where T stands for territory, G stands for geography. So how do we now join these? We want to select everything which is in this table. And then we do an inner join on that. But what are we joining on? We have decided to join on what? On sales territory. Now, Which sales territory joins on which sales territory? That is the most important thing. So, T dot sales territory. Tell me if you understand this. C dot sales territory key should be equal to G dot sales territory key. Who understands this query? Now, what we have simply written here is this. Select all from this table. Join what you have selected from this table onto this table. You are joining on this attribute where what is in this table, where the sales territory attributes in this table would match with the sales territory attributes in that table. So T stands for sales territory, G stands for geography. So what we are saying is that select all from dim sales territory, T, inner join dim geography on dim sales. Mind you, T here stands for what? Dim sales territory. So dim sales territory dot sales territory key. What this simply means is that you are selecting the sales territory key from the sales territory table. And wherever this matches with the sales territory key in the geography table, you select that. Do you understand? Now, which of these here represents what we have just described? Okay, I believe.
I think it's the first one.
Pardon?
I think it's the first one you have there.
No, I don't think so.
Okay.
I think it is this one. Whatever it is in this, take whatever it's in this and look for matching records in that. And where the two merge, select that point. So this is actually what we are looking at. This bit here. I didn't want to erase this, but it has gone. Okay, no worries, it has gone anyway, so that's fine. So what we are saying is that select whatever is in this one and whatever it is in this one, where the two merge. That is inner join. Right? The inner join. That is what we have just done. And let's see what we have when we do both. Okay, let's run these two tables first. How many rows does this give us? 11 rows. And how many rows does this give us? I think 600 and something. 655 rows. And let's see what we have when we do this. We have 655 rows, the same thing, which simply means that this has simply swallowed up all of that. This has simply swallowed all of that. So we are having a situation like this. You have this kind of situation. In this particular instance, but not always. And mind you, this and that are the same thing. This here and that are the same thing. Now, so this is an inner join, that's an inner join. Everything in this, where you're selecting attributes in this, which are also in that. Where there are matching record attributes in this, which are also in that. This is where they meet. In this particular case, so this is a special case of that. Okay? Now, with joins, once you have written your first statement, the other ones become pretty simple. If we do a full join on this, that should give us the same thing actually. We will look for a different data set where the inner join gives us something slightly different. And then we can see it clearer. Okay, well, yeah. Oh, I see. This gives us 600 and wow. Okay. So, okay, I see. Do you notice something? How many rows did we get
Just
here?
one more row.
One more row. So what this means simply, I think I must have made an error with this description here. I must have made an error with this description here. But it's pretty much that is the if it had the same number of rows, then that would have been it actually. It's more like we have just a little bit of that. It's more like something like this, right? So we have just a little bit of it out. So that gives us one more row. Yeah. Yeah, that's cool. That's good. Now, like I said, once you have done your statements, the next thing is just change your full, your inner, your full, everything to whatever other join you want. So with this, we can do left. We can do a left, and you would see that for this particular data set, it gives us the same result. Not to worry, we will do other data sets, then you will see different results. Let's do a right for this. Okay. This is also one less. A word of caution, though. A word of caution here. Never ever do a right join. Never ever do a right join in the workplace. Never ever do a right join. A right join is only good for academic purposes to explain what a join is. But in reality, it is not done. And why is that? Okay, let's take another data. Let me take a different data set. I'm not sure if I gave you addresses as one of the data sets, as one of the tables in the SQL HR table database I asked you to create.
You did.
You did.
Okay. So let's look at that. Select all from employees. What do I need to do here, guys? Can somebody tell me?
You need to change the table, the database.
Okay, I need to change the database. Select all from employees. And then, so if we have this is what we have. And let's see. This is what we have. Okay, so we have 109 rows of addresses. Right. Now let's see. Let's see what we can do with this. Let's see what we can do with this. Inner join. Inner join. What do we want to join? What do you think we should join on? Did you see any commonality? So this is the output for addresses. I'm going to run this again and see if you see any commonality.
Address ID.
Address ID. Address ID. So we want to join addresses. Okay, let's call this employees E, and let's call addresses A. Right? Now, the reason why we give aliases is because assuming this one, let's go back here. Assuming we didn't give an alias and we were to write all of this, how will it look like? It will read like select all from dim sales territory, left join dim geography, dim sales territory, left join dim geography, on dim sales territory, sales territory key should be equal to dim geography sales territory key. Do you see how long it is? But giving it an alias, you take the words away. You take most of the words away. And so your query becomes shorter and neater. So we want to join this. We want to join addresses. We want to join employees' addresses. So what we are looking at critically here is employees' addresses. That is the most important thing. We have the employee, we have the addresses. We want to see which employees live at which addresses. So we want where the two merge, inner join. So we have inner join addresses. A address has got an alias A. What are we joining on? We are joining employees' addresses. Employees' address ID, sorry. Employee address ID should be equal to addresses address ID. What is wrong with this? Did I get the spelling right or wrong? Oh, okay. Who knows what is wrong here? Who can see the error? One thing is being able to troubleshoot.
Addresses? Oh, that's correct.
Can anybody spot the error? Okay. So that's all the error. I called an alias here without declaring it. Do you get the point? Look at that. I called an alias here without declaring it. So immediately I declare the alias, the error goes away. And this is the result that we have for this particular query. So like we did before, we can just change this to join. How many rows did we get the first time? Let me see again. $108. $108. Let's see again something. Let me make this full. Do you notice a difference? Who has noticed a difference here?
135 rows.
What is the relationship between this query and that query? Now let's go up here. What is the relationship? Oh, we didn't write that query here. Okay. Oh, yeah, no, we didn't. We didn't just do the join. Okay, we didn't do just the join here.
We did full join.
Yeah, we did just the full join. But what I want you to notice simply is that the inner join is the same as join. So when you do not specify inner join, you are just doing a join. Inner join is the same as join, okay? So full join gives us that. And let us do a left and right join. And let us look at the outputs of these two critically. Forget about the number here for now. Forget about the number. I want you to look at something. Come on. I'm going to scroll down a bit and just keep a close eye. Right. Are all persons identified in this output? Are all persons identified in this output? Yes, all persons are identified. Now let's just run another query. And then you would understand my question. Mhm. I don't know. Let's see, let's run this. Let me expand this and let's see. Keep an eye on this, please. Do you notice something? Are all persons identified in this output? Are all persons identified in this output?
$106. So no.
Pardon? 106 is a no. Beautiful. That's all I want. That is all I want. Now, when you do a right join, chances of you, why would 106, why would we try to give an address to someone who is non-existent? Where does that happen? Only in Africa when we want to rig elections. Then we create, sorry for all the millions who will be watching on YouTube. That is quite so true. We create people ghost names. Some of you may have heard of what is called ghost names, ghost workers, right? Where the people don't really exist, but they are kept in the database.
And paid.
And paid. And paid. Yep. And that is so unfortunate. So we don't run a right join. And this is actually an interview question. You wouldn't do a standard SQL interview without getting this question. You wouldn't. You wouldn't do a standard SQL interview without getting this question. How do you resolve the issue of a right join? It can come in various forms. The question can be asked in various forms, but a right join is a right join and you never do it. So when you are presented with a case of a right join, what do you do? So like you have just noticed, it would work. It would produce a result, all right. It will. There is nothing wrong with it. In theory, there is nothing wrong with it. But in practice, it produces results that may not be favorable for business purposes, right? And you don't want that to happen. So how do you resolve the issue of a right join? It's quite very, very, very simple. All you would do is change your right to left. Change the right to left and swap the leading tables. Change the right to left. Let me write this here. Never do a right join. Change the right to left and swap the leading tables. So change right to left. This is the right. Change it to left. And swap the leading tables. Where are the leading tables? This and that are the leading tables. This and that are the leading tables. So what you do is just swap them up, swap them around. So change right to left, swap leading tables. Change the right to left and swap the leading tables. You don't need to do anything with the other parts. You don't need to do anything with the other parts of the query. That's all you do. And then let's see if the issue would suddenly go away. The issue was on row 106. Let's see if it would have disappeared. Has it gone?
Yeah.
Yeah. Now, so this is better for presentation, isn't it? It doesn't mean that the null has disappeared completely, but it is better for presentation because the null is still there in the background somewhere. That is it. But so in this with this particular result, you cannot say that somebody is there is no one at that address. There is somebody. The person may not have an address, but there certainly is someone. Do you get that? There certainly is someone. The person may not have an address, and that happens. There are people who don't have addresses. But we can have the situation where there are addresses without people. Right? If an organization were to have empty blocks of flats, what do you think would be the balance sheet at the end of the year? The business would likely be running in debt. And that should not be happening. So this is how you resolve the issue of the right join, and it is a popular SQL interview question: how to resolve the issue of the right join. Another one is how do you restricting the number of the rules of output. That's also a quite popular question. Any questions so far? Any questions so far?
No, not from me.
Not from you. Cool. Do you want to do this on another database? You can run the same thing on a different database. Let's see if we can get. Let's go back to AdventureWorks and see. It's like I've lost some of I have my crime data here. Let's see if we can do something on crime. Oops, where has it gone? Have I lost my database? Looks like I've lost my database. What's happening to my... Okay, let me reconnect. I haven't opened many tabs today, so I don't expect it to behave like this. Okay, I have everything. Let's see what we have under crime and see if we can look for something there. Okay. Select all from Chicago census data. Chicago census data. We're looking for commonalities now. Let's see if we can get public schools data. You can be running this on your end and let's see if we can get some commonality on which we can run our join on, because that's what I'm trying to look for now. Safety score. Area, community area. Hardship index. I don't think it has any commonality. Let's see. Okay, let me open it up here. This one is pretty long. This one is pretty long. Name of school. Is there a name of school here? Household. No, there is a name of school. Per capita income. We don't have that. There is no commonality to join on. Okay, let's forget about this stuff for this one. So we are left with cross join and self join. I think I'll leave those two for next week. I'll leave those two for next week. Cross join and self join. Actually, we can do cross join. We can do cross join, I think. Now, cross join is the situation like this. So with cross join, if we have And we have this, for example, to be and now. Come on. Okay, let's assume we have something like this, right? And then we have another table. We have another table. If we have this, what this simply is saying is that with a cross join, this here, A matches up to you take A, it will match up to if you take A would first of all match up to everything here. U, V, U, V, W, X. Then you take B. B would then match up to everything. U, V, W, X. In that, like that. So that's how the cross join works. So with a cross join, one has to be really, really, really very careful. Because if you have 10 rows of data, by the time you do a cross join, how many rows of data will you have?
100.
100. And if you have 100, by the time you finish, how many rows of data would you have?
10,000.
And if you have 1,000,000, you get the gist.
Yes.
So each item would match with each other one in both tables. Each one. So if you have 1,000,000,000 rows of data and you go and do a cross join, you should be ready to sleep let your computer sleep for 1 year before it wakes up. Yeah, so the cross join is actually it's not a commonly used join. It is normally used in mathematical applications because it's based on what is referred to as the Cartesian plane. I'm not sure if anybody is aware of what the Cartesian plane is. How many people are aware of what the Cartesian plane is? Cartesian plane. Who knows it?
I haven't heard.
Never heard of it?
No.
Oh, you have. You have actually heard of it several times. Only you haven't thought of it within that context. Did you ever do graphs in school?
Yeah.
Yep.
Oh, yeah.
So that's the Cartesian plane.
Cartographs.
Pardon?
I said Cartesian, I said cartographs.
Yeah, Cartesian plane. So this is your y-axis. This is can I draw it here like that? I hope so. This is your y-axis. And that's your x-axis. This is your Cartesian plane. And if you want to go further, you can do a three-dimensional to have your z-axis. So this is your y. Y-axis. You have your x-axis here. And you have your z-axis there. But we are not interested. We are just interested in the x and y for now. Right? So that is what the cross join is actually used for in giving ordered pairs, in creating ordered pairs of data, so that whatever is in this table would match up with every single one. Every single item in this table would match up with every single item in this other table. And if you happen to have 3 tables, as in this XYZ, then 10, if you have just 10 rows of data in each table, you're looking at how many? 100 times 10. That is 1,000 rows of data at the end of the day as your result. Right? And if you have 1,000 times 1,000 times 1,000, you know what that would be. Yeah, so we will look at that next week. I don't think we have enough time left now it's a short query. It follows the same pattern. It follows the same pattern as what we have already done. It is only the self-join that is a little bit intense, but the rest are just straightforward. So is there any question so far?